and all the ones who come together, or the 2's together, or the 3's and all the 4's together. Anyone else? We're still waiting for Khadija. She joined. Who else is now with us? I think we pretty much got everyone in. But in the meantime, in the morning, we were running a project, and we were running this workflow here. For some reason, it didn't quite work as I expected. There was a syntax error. And it is one way to persist data and to persist files. So here we got Docker run with a -v, where we bind our local file system, our local directory, to a folder within our container. So here we pull in bash latest image, we build a container, run that, and then we run a command which is bash -c we echo, right? Echo, this is a test. You'll just print that message, and sorry, we pipe that to a file over here that lives in the project folder in our container. And the interesting thing is that we've bound our local directory. We've mounted our local directory over to the that directory that lives on the container. So if we run that, we get an empty shell. But what is interesting is that if I ls, you will see that now I have my file.txt in my home directory. Okay, and if I do less my file, yeah, it has the input, or maybe cut my file. Yeah, it has the input, or rather the output from the container. So essentially, we've mounted our local file system onto the file system on the Docker container. We've run a command within it that persists and writes some output, which we can then capture in our local directory. Okay. I had another example here, which is we had created a volume that also allows us to run the same, but now we mount this onto a data volume that we, data volume was a volume that we created earlier using Docker volume create, and now we mount that onto our container. And if we run this command from another container, from another image, and we mount it, we are able to have access to that file. Okay, so that's something I wanted to illustrate. And you get better when you work through it. So in our resources, I'll try and put in a couple of tutorials, but I've updated the tutorial, and I'll share that with Percival, and we can all have access to that. Okay. In the meantime, then could we just then divide ourselves into groups? And the idea here, again, we can summarize. So there are two things. I can give you a file, and you can either summarize notes, or you're going to choose someone who will come and they will write down your discussions around how to structure bioinformatics projects, but largely discussing amongst yourselves on the best practices, or maybe share knowledge on how best to create directories or organize your computational biology projects and work. And this is really important because we've highlighted quite some high-level and advanced ways of working, Docker containers. We looked at Coda. We looked at all these virtual environments, multiple versions. We looked at Git. The question is then how do you bring all that together? How does that fit together within maybe what you're used to work with traditionally? Do I run my Docker container from my home directory? Do I run it using rights, sudo rights? If I'm an administrator, right? Where do I run my Git directory? How do I install it, right? So how do you work, or how does your current environment work? So if you could just maybe you choose amongst you somebody to come and maybe they can summarize how that group works and maybe what they've learned from each other and what they might think is a good approach to organizing these files and this sort of environments. Okay. So give us about 15 minutes or maybe 15 minutes to discuss and maybe another 15-20 minutes for discussion. And then I'll wrap it up by highlighting some common ways that have been recommended. And I'll just draw that from one of the really nice papers on how to do things. So if you look at the Journal of Computational Biology, every so often they will have a best practices tutorial or something, somebody to summarize things, and these are really, really, really awesome to take home and think about. Okay. Sawa. All right. So I'll just name one. So just say 1, 2, 3, 4. 1. I know Passive is not part of that. Oh, do you want to join? Yeah. Passive is a software engineer and a bioinformatician, is it? Yes. Yes. Yeah. So 1, 2, 3, 4, then 1, 2, and so on and so forth. We start that way and come to the end. So 1. 1.
1, 2, 3, 4, 1, 2,
4. 1. Okay, so all the ones together, I don't know, maybe on this corner. Yeah, all the ones here, and all the 2s here, all the 3s here, and all the 4s over there.